In this video, we are going to solve a few questions to reinforce the ideas that we've already talked about. But what I want to highlight before we do that is the 4 stages of competence. Because there's a big misconception with geometry. Students believe that by repeatedly solving questions, they would somehow magically become competent with geometry. Because teachers cannot accurately explain the ideas and project the ideas and teach the students how everything fits, they take them to the stage of unconscious competence, which basically means that the skill becomes second nature. So by repeatedly doing questions, they try to reinforce the skill, which is not a good long-term strategy. And so ideally what you need to do is, you need to analyze what you're doing and why you're doing it. Right, so basically when you're starting geometry, you probably don't know what you don't know. So you are completely clueless, right? Then you realize what you don't know. So you have a very vague idea of what you don't know. And then you slowly gather information and get some proper mental frameworks and you start to develop a skill. You understand the how and why. But in order for you to get to the highest stage of competence, which is unconscious competence, the way you think of unconscious competence is like opening a door handle. You understand that in order to open a door, you need to push the handle down. But you don't consciously think about it. You don't actually think about it. You do it by instinct, right? Because it becomes second nature. That's ideally where you need to get to. But before you get to that level, you need to do tons of practice questions with the correct frameworks. Not practice questions without any proper frameworks. Because then you're just trying to mimic your teacher, but you can't because they have done tons of questions and they understand the patterns of questions. So ideally, you need to have a proper framework in mind. And that's exactly what I'm going to show you when we solve these problems in this lesson. So let's recap what we've done thus far. If I zoom out, you can see that we've talked about lines. This may not be very visible, but on the first line, we talked about lines and angles. Under lines, we talked about perpendicular lines, parallel lines, and transversals. We said when we talk about transversals, and when we start linking it up to angles, which is on this slide, then we have the fun angles, right? We've talked about the different types of angles that we can get. So the first line, we talked everything about lines and angles. On the second row of slides, you can see that we talked about triangles, the different types of triangles, and we spoke about 2 main types, which is the isosceles and equilateral triangle. And then we went on to talking about similarity and congruency. Now, this is extremely important, that when you are given any question, you need to keep these frameworks at the back of your mind. So if I zoom into the first mind map, you would see exactly as we've structured it: lines, angles, triangles, and then polygons. And so when you're given a question, so the questions that we'll work with now will only be dedicated for lines, angles, and triangles. You need to think about all of the subcategories, everything that comes under lines. What are everything that comes under lines? Perpendicular lines, parallel lines, transversals. What are everything that come under angles? Adjacent supplementary angles, adjacent complementary angles, adjacent angles, vertically opposite angles, revolutionary angles, corresponding co-interior and alternate angles. Right. Then when we move on to triangles, we need to think about isosceles triangles, equilateral triangles, similarity, congruency, and all of the things that comes with triangles. Some angles in the triangles, the exterior angles of a triangle is equal to the sum of the interior opposite. And so when we start building on these frameworks, when you're given a question, the first thing that you ask yourself is, am I given a line? Well, obviously you have to be given lines, because if it was any other way, you wouldn't be able to see the question. So lines will always be there, will always exist. Then you ask yourself, am I given angles? How would we know if we are given angles? Well, 2 lines will meet. The point that they meet will form an angle. So if you're given an angle, then you need to think about all of the categories that come under angles. And then if you're given a triangle, it has to be a 3-sided polygon. So it's quite distinct. It has a very strict criteria. Then you think about everything that we talked about under triangles, like some angles in a triangle. The exterior angle of a triangle is equal to the sum of the interior opposite. Isosceles triangles, equilateral triangles, similarity and congruency. And so if you continuously use this mental framework, eventually you will start answering questions based off instinct. And this was the breakthrough for me when I solved these questions, because I could never understand how or what thought process teachers went through, because they basically just solved questions just because of the years of experience. But if you're explaining this to child that has no experience with geometry, that's doing it for the first time, then you need to put it down in a rigid way of understanding. If you can do it based off your instinct, then that's good. But what I'm saying is, while you have the time now, practice using these mental frameworks so that you have a good foundation. So from now and then, just keep testing your understanding. Right? Go back and try to decode the question into its simplest form. Because the thing is, if you're given an extremely difficult question, then you eventually have to come back down to this mind map. Alright? A question that let's say there's a question in the exam paper that you can't solve. Then you have to come down to this mind map and run through the checklist and see what you're missing out. Because it has to be one of this. Otherwise, if it was something else, then we would have taught it. But it's not. This is the entire syllabus displayed to you. Right? So let's go on and solve these problems and run through this exact framework. Okay, so this is how we are going to structure our geometry. On the first line, we're going to have required to prove. So this is basically what the question is asking. Because if you don't understand what the question is asking, then there's no point in even us proving the question. Then we will write our given information. So this, exactly as we've talked about in word problems, is we'll use known information to find unknowns. But the most essential part is the calculation and the reasoning. So even if you don't want to follow this format, at the very least, you need to have the calculation and the reasoning. So basically what I'm saying is, with your calculation, you will show mathematically how you get to the answer. But if you're using one of the reasonings of maths, like vertically opposite angles, adjacent supplementary angles, adjacent complementary angles, or one of the theorems, you have to state it as a reasoning. Right? Because you cannot use a theorem without stating it. It's exactly like how when we use theorem of Pythagoras, we're supposed to state where that theorem comes from. So here's a list of all of the acceptable reasoning that your child can use when making use of some theorem, right? You can see here the Department of Education broken down into lines and angles, right? That would have been a better statement here. Then triangles, circles is what we will do next year. Do you remember I had circles on the mind map and I said that's a grade 11 topic? Can you see where that comes in, how it fits in? And quadrilaterals. So quadrilaterals is what we will focus on, and lines and triangles. So for now, at a grade 10 level, 1, 2, and 3 are the topics that we will focus on and the reasoning that we will use extensively. Right, so please keep this in your book. Even if you have to cut this out and stick it in your book, make sure that you do, right? This is from the Department of Education. So ensure that you have these reasoning. Right, so let's start solving these problems.